Boom. Hello and welcome back to Calculus 1. We are going to review for Calculus 1 exam number 3. On chapter 4, about 10 problems, same specs as always. As I mentioned, 4.8 really can't be on a test because of the high dependency on these calculations. But other than that, everything else is fair game. We have application of derivatives. Now, it's important for you to write down now that there will be a separate problem for the first derivative test, where you have to write the conclusion of it. Second derivative test, separate problem. And then a separate problem for min-max, word problem for optimization. So that's already 4 problems. Now, a problem for graphing. I'm going to give you all of the specs. I'm going to tell you where the vertical asymptote is, horizontal asymptote, x, y intercepts. So I will give you everything. You don't have to compute anything in that problem. Not a single thing. You will not even have a function given. You are only going to have a table with values. So you will know that your vertical asymptote is at 6. And you will know that your horizontal asymptote is at -1. You will know that your maximum point is at 3, -4, right? So you are going to have all of those details, and then you will just need to, plug all of that on a graph provided. And so that saves about 40 minutes, right? And a lot of points, because what happens when you mess up the first derivative? Everything is wrong, because immediately second derivative is wrong, and then first derivative test, second derivative test, increase, decrease, critical points, inflection, everything wrong, right? So to avoid that, I'm going to have one problem for first derivative test, one problem for second derivative test, one problem for graphing where everything is given, one min-max problem, which is critical points and stuff like that, and then a problem on optimization. That's the word problem. We have a problem that will have parts A, B, C for integration. All right, so number 1, min-max. Number 2, first derivative test. Number 3, second derivative test. Oh, by the way, for the problem of second derivative test, I don't know why, but a lot of students actually go and solve everything for the first derivative. Why? It's a second derivative test. Just, I don't care what the critical points are and stuff like that. Just go first derivative, take the second derivative, and then do the problem. There is no need to look for critical points and increase, decrease. No one cares, right? There is a problem for that here. So when you see the second derivative test, just do second derivative test. And don't worry about the first derivative calculations. You have to find first derivative so you can find the second derivative. That's clear. But you don't have to set first derivative to 0 and get everything, because that's not that question. Number 4, graphing. And I'll see everything is given. So no, you're not calculating anything there. That's number 4. Number 5 is the optimization word problem. Mean value theorem statement plus find C. If you paid attention, you know what it means, find C, because we also have find C for integrals, right? That's a separate thing. Number 7. L'Hopital. We know it's 0 over 0, infinity over infinity, and I say and other. The other ones have to be converted into the basic ones. And finally, number 8 is integration. This will be like, you know, ABC. So 4 or 5 integration problems in the same problem for maybe 15, 16, 20 points of the whole test. And you guys know that chapters 5, 6, and 7 are all integration. If you don't know 4.9, well, your math education is over, right? Because you can't do those 3 chapters. That kills your Calc 2, and you're done, right? So 4.9 is extremely important section. Now, when I say integration, I will put in parentheses find C. I don't want to say I never put it on the test, because I did put it on the test for Calc 3. So, you know, find C is something that it's not as often there, but it's a very important technique that you need to know. So that's the exam. Again, depending on the spice level, you might have the replacement question in the back, and then everything is the same. About hour and a half of work, right? I mean, hour 20, but then we kind of push through the break as well if you need to, and so on. So, yes?
The section that was an homage to our ancestors, like linearization, that's not on this.
Thank you. That will definitely, linearization, before you leave, linearization and differentials. Okay, whew. In blood. Linearization, guys, linearization is the tangent line. Holy nightmare. This must be there because it is a tangent line, and I said that all of your exams will have tangent lines on it. So yeah, linearization is extremely, extremely important. So linearization is definitely there. The word problems for differentials, the problem can say, let's say, find square root of 17 using linearization, right? Find square root of 17 using linearization, in which case you will use linearization, but it can say find square root of 17 using differentials. And that can be done as well. So linearization and the differentials. And maybe I can, before I dive into these problems here, maybe I can look into, oh wow, it's 1:10. You know what, we're going to extend the class. If anyone needs to leave, obviously all of this is streamed. I'm going to extend the class so I can solve, some of these problems that are here. And then hopefully you'll have your TA as well on... I don't think that any of the services are actually opened over the weekend for the summer. They might be open on Friday. Maybe the website would say, yes?
What sections are in the exam? So if I want to go watch the streams again, which section?
Well, this is everything except 4.8.
Except 4.8?
Yeah, so everything. Okay, so figure out square root of 17 using linearization. So that would be, we have the f of x to be square root of x, and f prime of x to be 1 over 2 root x. So these are our things that we need, and we'll need this for differentials as well. So linearization way would be to say L of x is equal to f computed at a. Now we are doing this at x equals 16, right? So linearization, so f computed at a, that's the square root of 16, plus 1 over 2 square root of 16 times x minus 16. And this will give us the linearization formula. Guys, when I say linearization formula, you are getting the tangent line, all right? And then you will just plug in 17 into that line and you're done. So square root of 16 is 4 plus 1 over 8 times x minus 16. That's 4 plus 1 over 8x minus 2, which is 1 over 8x plus 2. So our linearization for the square root at 16 is simply 1 over 8x plus 2. And now we will say that square root of 17 is approximated by L of 17, which is 1 over 8 times 17 plus 2. And now you do this calculation, which is 17 divided by 8 plus 2 gives you 4.125. Now you know this is good because square root of 16 is 4 and 16 is just below 17. So square root of 17 should be just a little bit bigger than 4. And we have 125 there. So that seems good. Now same problem with differentials. So square root of 17, right? So what you do for differentials is you compute dy is equal to f prime of x delta x. Your delta x is new minus old, right? So you are going to go with 17 minus 16, which is 1. And right, because you are trying to see the change from 16 to 17. So it's 17 minus 16, because change from 16 to 17 is going to be 16 is old, 17 is new, so 17 minus 16. Because it could go the other way, right? Delta dy is equal to derivative computed at 16, so that's 1 over 2 root 16 times 1. And that is 1 over 8, which is 0.125. You can see it stirring, right, in a distance. So now, what is the square root of 17? Square root of 17 is the square root of 16 plus the approximate change. Well, that's 4 plus 0.125, giving you 4.125. Ta-da! Okay. There are a lot of cool problems here. Beautiful. Look at this. Woo, shiny. Oh, you want me to solve the whole lab 4? Sure.
Oh.
It's okay. It's fine. You can stay there.
That would be great.
All right, let's
Maybe go stream it.
see. Oh, really? So ninjas can't get it. I can't wait for the Tuesday in my Calc 3 when they all gonna show up. It's it is going to be. Oh no, they're not having it.
Oh, they're not having it.
But we have quizzes leading up to that day, so.
One of them randomly watches this. But that's the same logic for now, right? Because you're doubling up and confusing. They won't know until the last morning, which is number 7.
Yeah. Well, as soon as they see the double quiz on Saturday, double quiz on Sunday, will be clear that pushes. That's the basic IQ. I mean, we'll see. All right. So, what am I having here? Locate the critical points of the function f of x equals 1/4 x to the 4th minus 2x cubed minus 18x squared plus 216x. So we want to do the min-max on this one, and then they said use the second derivative test to show if they are min-max. We can achieve that with the first derivative as well. So let's see. So I need the derivative of this. That's going to be x cubed minus 6x squared minus 36x plus 216. This is amazing. Who came up with this? All right, fine. So now we need to factor this. Obviously, that's going to be Wolfram alpha.
Well, we're not going to have Wolfram alpha on the exam.
Exactly.
It's in the study guide. That's where I got it. From our study guide from the the one that he said you should go through because he gets his questions from there.
A lot of those problems just try to trip you up in the arithmetic. It's not actually the concept. It's kind of annoying.
Yeah. Vast majority is just annoying without. Yeah. I asked Wolfram alpha to factor this in all of its infinite wisdom, and this is what it came up with. Our first derivative is equal to x minus 6 squared times x plus 6. So what I have here is the, when I set it equal to 0, I have x equal to 6 and x equals to negative 6. So these are the two values that are critical points. Now, there are going to be y values for this when you take these numbers and plug them in original problem, which I'm not doing. But there are going to be, 6 comma something and negative 6 comma something, and these two are min or max values, right? So now they are suggesting to use the second derivative to see what's what. And we can actually do that to, honor their wishes, because we can find the second derivative, and that's going to be 3x squared minus 12x minus 36. And you can factor out 3, because you have to set this equal to 0. That 3 is going to die and make everything else easier, actually. So you have this. And when you set this equal to 0, you will find inflection points, and it will be easy for us to. So how about x minus 6 and x plus 2, right? So x minus 6 and x plus 2 as factors. So x is equal to 6 for an inflection point, and x equals to negative 2. Guys, you see that we actually ran into this issue over here, that you have that critical point is 6 and then inflection point is 6. Well, guess what? Inflection point is stronger. So if you get the same number for critical and inflection, it's inflection, okay? So because of this, we are not going to have this up there. Okay, so that's that, and so look up. Now I have my partition, and partition is happening at negative 2, and partition is happening at 6. The value that I have as a min and max is at negative 6. So all I care about is whether I have concave up or concave down between negative infinity and 2. If it's concave up, the point is the minimum. If it's concave down, it's a max. So I'm going to pick a test point. I can pick, let's say, negative 3. So second derivative computed at negative 3 is 9 plus 12 minus 12. That's 9. So that's bigger than 0. So that's concave up. Concave up has a minimum. Has a minimum, which implies that negative 6, blah, whatever, is a minimum. You obviously go and you compute your y value in that long expression. This is a very good representative of min-max problem that will be on the test. Clearly not as annoying in terms of numbers, but it's a very good thing because you get to do first derivative, right, set equal to 0, find critical points, and then figure out whether those are min or max. Now, if you are going to do that min-max thing with first or second derivative, I don't care, okay? You can do the first derivative test because you will get increase, decrease, right? So there's your maximum, there's your minimum, right? Or you will do second derivative test where you say that, okay, on this interval I have concave up. Concave up looks like a U that has a minimum, right? So that's that. So that was a good problem. That was a winner. Says a quiz question. It's like it didn't even try to white it out.
When you go back to it, it's never the same, so it doesn't really matter.
Yeah.
They always change.
Wait, is that a quiz question?
Yes.
Look at his eyes light up. Like, oh, there he is.
It changes. Once you go back into it, it
I mean, sometimes it gives you this.
will you shut that up? Like,
You think I don't know that? It's going to be refresh, 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 refresh. No, you can't do that because it refreshes all 5 problems on the quiz. So you can't do that. Or maybe you have infinite time, just like me. Oh, no? Okay.
well, give us something like that.
Here.
Just change the value.
Oh, no. Here. Like.
No, it's not like that.
All right. So we have a cylinder. Cylinder is a 3D object which has the radius and the height. We already learned in this class, hopefully, that the volume for this, right, it's not spiky, so it's area of the base times the height. So volume for this thing better be pi r squared times the height h. They say approximate the change in volume of the right circular cylinder. That means the edges are straight because we can tilt it. Of the radius 19, as its height decreases from 14 centimeters to 13.9 centimeters. Guys, technically, what this is you have a soda can, you put in a straw, and you do the sip. What happens with the height? It's going to go from 19 to, or from 14 to 13.9, right? Actually, there is a statistic. If you look up on for the average sip, thank you. I just lost the word on Google, and I actually created one of the project problems on drinking with a straw. And then let's see, how well the average data holds to your own experiment. It didn't end up on your project, but it's in a circulation. So if you retake the class, maybe. Please don't. It's a bad day. So we know that we are looking for to approximate the change in volume with dV. Now, dV is when we take the derivative. Now, please understand that height is the one that changes. That's the variable. Radius is the same, right, as you are sipping. So radius is the same because the can is always the same, unless you crush the can, obviously. But then, you ever done that when someone is drinking, you go and crush the can?
No.
Water bottle, yeah, but can is better. All right, so the derivative in respect to, so we can actually plot. You didn't like that. Did it happen? I'm fine-tuned to single them out. Yeah, I know. Well, as a disclosure, it never happened to me. I know the concept from YouTube. She's like, that's not funny. with a burning stare. And I'm just going to quote, look at the democracy, all right? Vast majority is laughing, so.
Especially since someone didn't vote the right way.
Ooh.
No, I'm looking behind it. Another
Oh, okay. 19 squared pi age. We have to put 19 in because it is going to be constant radius and only height is changing. So now when you take the derivative of this, you are going to have 19 squared pi dh, right? So that's our formula. And then we see that this dh over here is negative 0.1. Negative 0.1? Yeah. We are getting volume that is shrinking. So it's a negative change, right? So now I'm going to calculate the change in volume by 19 squared pi times negative 0.1, which is equal to some number, and you are done. Awesome. That was a good problem, good quality. I use the derivative to determine local min and max of the function. Ooh. The intervals increase and decrease. Catch the possible. Oh, I can pretty much see where everyone goes wrong on this problem. They are asking you to find min and max, and what are you used to do for min and max? You find the first derivative and you set it equal to 0, right? So this is what the problem has. So what's interesting about this? Oh, it's 2x. Find min max. Can
People try to take the derivative.
Yes, they gave you the derivative, so don't take it anymore. Just leave it. Just equals 0 and you're done, okay? This is already the first derivative because there's a prime there. There's a prime over here. So if you take the derivative of this, you will have a second derivative, and that's inflection point, so obviously it's going to be wrong. They gave you the first derivative. Please read notation carefully. So all you need to do is to set this puppy equal to 0, right? You are going to get your 0, pi over 2, pi, and so on. And from that point on, you will be able to solve. So you are solving equation sine 2x equals to 0, from where 2x is equal to 0, 2x is equal to pi, 2x is equal to 2 pi, and so on, because sine is 0 at all of those values. And then when you divide, x is 0, x is pi over 2, x is pi, and so on. So at these values, you have min and max. I mean, there's more, but this is where the min max are. And then you can either use common sense or you can do the first derivative test. I would rather use common sense because I already know that the integral of sine is cosine, right? So the original function is cosine, and the cosine graph, integral of sine is negative cosine, so it's going to, the original function looks like this. So at 0 you have a minute, right? But that's already advanced stuff, right? So you can do these and then choose a test point and then see what's min, what's max. So yeah, if you're messing this problem up, just stop taking derivatives when they're already taken. Read the notation. That was a beautiful problem. Amazing. Make a complete graph of a function. Well, I will be giving you the specs. So I'm skipping this problem because it's going to take 40 minutes for no reason. Another one, sketch the graph of the following polynomial x cubed. Again, everything is given. So your job is to draw the function. Show that the general quadratic 4-degree polynomial has either 0 or 2 inflection points. Okay, so they're giving you. Now, this is actually a problem that would end up being on the honors exam, but I think it's a cool learning experience. So they give you x to the fourth plus ax cubed plus bx squared plus cx plus d, and they're asking about inflection point. Well, hit this with the second derivative. So first derivative is 4x cubed plus 3ax squared plus 2b, or not 2bx, plus c. And then we have f double prime of x is equal to 12x squared plus 6ax plus 2b. And has 0 or 2 inflection points. Good. So now what you are supposed to do is equal this to 0, right? Now when you equal this to 0, well, first, no, you're going to factor out 2. That is 6x squared plus 3ax plus b equals 0. There we go. And now you unleash quadratic equation, and from there you will see exactly what's happening. Because you need to solve this, and you don't have what a and b are. It's just in general. So what you do is you solve the quadratic. So it's a negative b, so negative 3a plus minus square root of b squared, that's 9a squared, minus 4 times 6 times b, divided by 2a, which is 12. So that's negative 3a plus minus square root of 9a squared minus 24b divided by 12. All right. 0 inflection points or 2 inflection points. So when do we have 0 inflection points? 0 inflection points when 9a squared minus 24b is less than 0. Because in that case, the whole thing becomes complex number, and that's not a value that you can have for inflection point. So if the thing under the radical is negative, then you have a complex number and you can't have inflection point. But if it's positive, 9a squared minus 24b larger than 0, well, in that case, yes, because you solve this equation, inequality now, and you will get exactly the situation they ask b to be smaller than 3a, right? So you have 9a squared larger than 24b. You move 24 over. You cancel this to get 3 over 8a squared less than b, which is exactly the thing they have in the paper. So that's good. Make the complete graph. That's another thing. Give you everything. I would say don't worry, even though this is on a quiz. Yeah, I'll have to revisit this quiz. And then we solved everything else. Wow. So the last problem, can you imagine I went through everything? Skipping 3 problems that are graphing, because I'll be giving you...
Well, that was only 4.1 to 4.3 or 4.4.
Yeah.
Yeah.
Right. Consider the quadratic function ax squared plus bx plus c, where a cannot be 0, so this must stay quadratic. Show that the mean value theorem applied to the interval number c guarantees the midpoint, is guaranteed to be the midpoint of the interval. So we are on interval a to b. Okay, so this is going to be ab squared plus bb plus c minus, we plug in a squared minus ba plus c divided by b minus a. So just plug stuff in, and now you have ab squared plus bb plus c minus a squared plus minus ba minus c, c is die, divided by b minus a. And we can factor out capital A, which gives us b squared minus a squared, plus factor out b, which gives us b minus a, divided by b minus a. Then the first one factors into b minus a, b plus a. What a cool problem.
Yeah.
And then divided by b minus a, and you can finally factor b minus a, and that leaves us with a plus 1 divided by b minus a, and then these die, and we have that b plus 1 is equal to, and I neglected writing derivative. I am a terrible person. I'm supposed to write the derivative on the other side. So the derivative of ax squared plus bx plus big C is supposed to be 2a and then lowercase c plus b. That's the derivative. Derivative, so f prime computed at little c. And now just solve for little c. So we have a over b plus a plus 1 minus b divided by 2a is giving you a little c. And there it is. That's the formula. Nice. I like this. All right. Fun. I'll see you tomorrow. I'll see you on Monday.